This is another truss problem. You can see the given, and then they ask us to find the forces in all the members and indicate if it's in tension or compression. You see there's a roller at point A. Oops, sorry, that was my cat. That's A. I forgot to label them. B, C, D, and E. But you see there's a roller at point A, and then at D there is a pin. And so we're going to solve this. The first step is always to draw a free body diagram. So I'm going to draw a free body diagram quickly. I'm just drawing all the members of the truss. And then we replace the pin at D with a X and Y component of a force. So dx, dy. Let's see, this is the 400 Newton force that was already there. And then we have that force to do the roller. So NA. And I'm going to go ahead and put in all the dimensions and the labels. So A, B, C, D, E. And then it's 2 meters is the overall height and 2 meters for each of the sections here. So for this method, we need to have joints that only have two unknowns. So if we look, we actually I don't see any zero force members either. So we'll need to start just by doing looking at the whole system. And so we'll do that. Now we've got the free body diagram already drawn. So I can sum the moments about point D, because there's a lot that we don't know at point D. There are two unknowns, to get us to the NA. So that's going to equal 0 because it's an equilibrium. We're doing as counterclockwise as positive, or coming out of the board as positive. And NA is gonna create a moment that's going to be negative. If I do the right hand rule, my hand's going into the board, so negative NA, and then times that perpendicular distance to that force, which is 4 meters. And remember, you can think about it that force just moves up to here. We can move it along the line of action. So we're just interested in that perpendicular distance to that force. So NA times 4 meters, and it's in the negative direction. And then we have that 400 Newton force, which will do the right hand rule. It creates a positive moment. So 400 newtons times, and then this one, the perpendicular distance, that D is going to be 2 meters. And that equals 0. And so we get a NA to equal 200 newtons. Let's go ahead and start solving with joints. We could also solve for dx and dy. I think I'm going to skip that for now just to see if we might not need to. But let's just start over at joint A. So we're going to start with this one, and then we can find this AB and AE. So joint A, I'm going to draw the joint. And then you always want these forces to actually touch that particle. So we have NA, we have AB, and then we'll have AE. So AE, I think it's going to be in compression because it needs to counterbalance that NA. And then AB is going to need to point to the right to counterbalance that AE. So AB. And then we know that this is 2 meters over and 2 meters up. So this angle here would be 45 degrees, or we can do that 1 square root of 2, which is the way I like to do it. So I'm going to write that on this one, 1 square root of 2. And now we can sum the forces in the x direction equals 0. and sum the forces in the y direction equals 0. And we know NA, we already found it equals 200 newtons. So I'm going to sum the forces in the y direction equal to 0, and we get NA, which is at 200 newtons. It's pointed up, so it's positive. And then minus that y component of AE, which is 1 over square root of 2 times AE equals 0. So AE equals 200 times the square root of 2. And that's going to be newtons. And I got a positive number, so that means I was right about it being in compression. And I'm going to go ahead and multiply that out. So AE equals 282.8 newtons in compression. All right, so we found one. That's AE. Now let's sum the forces in the x direction. So we can find that AB equals 0. So we get negative that x component of the AE. So 1 over the square root of 2 times AE plus AB equals 0. And AE we already found, and with the square root is 200 times the square root of 2. So we get AB equals 1 over the square root of 2 times AE, which is 200 times the square root of 2. So this cancels out. They're newtons. And we picked the direction right, so it is in tension. So AB equals 200 newtons, and it's in tension. So go up here, we found this one. Now we can either go to, let's see, now if we go to joint B, if we went to joint E, we would have 3 unknowns, right? Let's see, if for joint B, we don't know that, we don't know that, and we don't know that one. Instead, I'm going to go to, but if I go to joint B, BE is unknown and BC is unknown. I can deal with 2 unknowns because we're doing this method of joints. We can sum the forces in the x, sum the forces in the y. So let's go ahead and draw a free body diagram for B, joint B. And for that, we have that 400 Newton force pointed down. This is B. And then we have BC pointed to the right. We have BE. And we have AB. Yeah. And we already found AB is 200 newtons in tension, which is the way we drew it right here. We don't know BC and BE. We can sum the forces in the x direction equals 0. And we get negative AB plus BC equals 0. So BC equals 200 newtons in tension. And then we can sum the forces in the y direction equals 0. And that gives us BE minus 400 newtons equals 0. So BE equals 400 newtons in tension. So now we have BC and BE. So we've got this one and we've got this one. Now we can go back up to that joint E, because now we just have the 2 unknowns for joint E. So let's do a free body diagram for joint E. And joint E, we're going to have AE and BE. Let's see. AE, AB, CE. and then DE. See, AE we've already found was 282.8 newtons in compression. That was also 200 times square root of 2. That's AE. BE we also found was 400 newtons in tension. That's 400 newtons. And then CE and DE. So we don't really know what direction these are going to be in, so I'm just going to make them both in tension. It doesn't make sense to me which way they would be. And now we can sum the forces in the X and the Y direction. I'm going to start with the Y direction just because DE is all in the X direction, so we only have one unknown in the Y direction, that's CE. So sum the forces in the Y direction equals 0. These are all the 1, 1 square root of 2, 1, 1 square root of 2. And so we get AE, or we want that Y component of AE, so that's 1 over the square root of 2 times 200 square root of 2 newtons, and that's pointed up, so that's positive. And then we get minus, and BE is pointed down, it's 400 newtons, so minus 400 newtons. And then minus that CE, or 1 over the Y component of CE, so 1 over the square root of 2 times CE equals 0. So we can multiply that out. I should have written that lower, but see, these cancel out. So CE over the square root of 2, I just moved it to the other side, equals negative 200. So CE equals 200 times the square root of 2 newtons, and I've got a negative number, so that means I guessed wrong. It was actually in compression. And 200 times the square root of 2 is at 282.2 newtons in compression. All right, cool. So now we have CE, and now we can sum the forces in the X direction equals 0. And we have AE, which is pointed to the right, so that'd be positive. So 200 square root of 2 times 1 over the square root of 2, because it's just that X component. BE is in the Y direction, so there's no X component. CE is actually in compression, so it would be negative 200 square root of 2 times 1 over square root of 2, and then plus DE equals 0. And so the way this works is that, because we had gotten CE basically equals the negative 200 times the square root of 2 newtons, so we can either put that in for the CE, or you can sort of move that arrow around because now you know it's actually in compression. Either way will work. So we end up getting DE equals, so we have 200, the square root of 2's cancel out, so 200 minus 200, which is 0, so DE equals 0 newtons. So now we have CE and DE. Let's see. I've got this one and that one. And so we're almost done. The last thing we have left is that CD we still need to find. And so let's do the joint C. So joint C, we have CD, we have BC, and we have CE. CE was 200 times square root of 2 in compression. CD we found to be, or CD is what we're looking for. Yeah, CD is what we're looking for. And then BC was 200 newtons in tension. So tension is 200 newtons. And so basically we need to find that CD, so we can sum the forces in the y direction equals 0, and that CE has a y component, so that's 1 over the square root of 2 times 200 square root of 2, and that's in the negative y direction, then plus CD, which is all in the y direction, that equals 0. And so we get CD equals, the square root of 2's cancel out, equals 200 newtons, and that is in tension. So now we found CD also, and so we're done. So we found all the forces in all members, and then we indicated if they were in tension or compression.